Today we're going to talk about bisectors in triangles. Our vocabulary for today is concurrent, point of concurrency, circumcenter of a triangle, circumscribed, incenter of a triangle, and inscribed. Go ahead and get your laughter out now at the vocabulary so that I don't have to listen to it tomorrow. I know, everyone's going to think circumscribed is a funny word. That's fine, move on. Since a triangle has three sides, it has three perpendicular bisectors. When you construct the perpendicular bisectors, you find that they have an interesting part. The perpendicular bisector of a side of a triangle does not always pass through the opposite vertex. When three or more lines intersect at one point, the lines are said to be concurrent. The point of concurrency is the point where they intersect. In the construction, you saw that three perpendicular bisectors of a triangle are concurrent, which we see here below. The point of concurrency is the circumcenter of the triangle. So the circumcenter is point P, where BP, AP, and CP intersect. The circumcenter can be inside the triangle, outside the triangle, or on the triangle. Here are three examples. In an acute triangle, it will be inside, obtuse, outside, and right will be on the triangle. The circumcenter of ABC is the center of its circumscribed circle. A circle that contains all the vertices of a polygon is circumscribed about the polygon. So points A, B, and C are all touching the circle. Using properties of perpendicular bisectors. DG, EG, and FG are the perpendicular bisectors of ABC, and we want to find the length of GC. G is the circumcenter of ABC. By the circumcenter theorem, G is equidistant from the vertices of triangle ABC. Therefore, GC is congruent to GB, or GC equals the measure of GB. We substitute 13.4 for GB and find that GC is also equal to 13.4. Next, we're going to use this diagram to find GM. MZ is a perpendicular bisector of triangle GHJ. The circumcenter theorem says that GM is equal to MJ. We substitute 14.5 for MJ and find that GM is equal to 14.5. KZ is a perpendicular bisector of triangle GHJ. And using the circumcenter theorem, we know that GK equals KH. So we substitute 18.6 for KH and find that GK is equal to 18.6 also. Using this diagram, we want to find JZ. Z is the circumcenter of GHJ. By the circumcenter theorem, Z is equidistant from the vertices of triangle GHJ. By the circumcenter theorem, JZ is equal to GZ. We substitute 19.9 for GZ, so JZ is 19.9. To find the circumcenter of a triangle, we want to find the circumcenter of triangle HJK with vertices 0, 0, 10, 0, and 0, 6. So first we graph the triangle, and I've labeled the points for you, H, J, and K. Next, we need to find the equations for the two perpendicular bisectors. Since two sides of the triangle lie along the axes, we can use the graph to find the perpendicular bisectors of the two sides. The perpendicular bisector of HJ is x equals to 5 because x goes from 0 to 10, so x equal to 5 is halfway. And the perpendicular bisector of HK is y equals 3 because y goes from 0 to 6 and 3 is halfway. Finding the intersection of the two equations is the next step. So we have the two lines graphed here. I've labeled x equals 5 and y equals 3. The lines x equal to 5 and y equals 3 intersect at the green point, which is 5, 3, and that is the circumcenter of triangle HJK. A triangle has three angles, so it has three angle bisectors. The angle bisectors of a triangle are also concurrent. This point is called the incenter of the triangle, and the incenter of a triangle is equidistant from the sides of the triangle. The distance between a point and a line is the length of the perpendicular segment from the line. So unlike the circumcenter, the incenter is always inside the triangle. So here's an example of an acute, obtuse, and right triangle, and they're all located inside the triangle. The incenter is the center of the triangle's inscribed circle. The circle inscribed in a polygon intersects each line that contains the side of the polygon in exactly one point. This is called a tangent line, where it only intersects at one point. MP and LP are angle bisectors of triangle LMN, and we want to find the distance from P to MN. P is the incenter of LMN. By the incenter theorem, P is equidistant from the sides of LMN. The distance from P to LM is 5, so the distance from P to MN is also 5. Here we have QX and RX that are angle bisectors. Triangle PQR, find the measure of angle PQX. Because XR is the bisector of QRY, we say that measure of angle QRY is equal to twice the measure of XRY. Because if it's bisected, it's cut in half, so the whole thing is equal to twice one of the halves. Substituting 12 for XRY, we get 2 times 12 is 24. The triangle sum theorem says that PQR plus QRP plus RPQ is equal to 180 by the triangle sum theorem. Substituting, we get QRP as 24 and RPQ as 52, which is labeled in the diagram. We can subtract 76 from both sides and find that measure of angle PQR is 104 degrees. Since QX is the bisector, we substitute 104, and PQX is equal to 52, half of 104. Here's your lesson quiz. Go ahead and try some of these problems. See if you can answer them. If you have any questions, please ask before class tomorrow, and we'll continue to do some applications with this.